Since we're talking about virtual production, we thought we'd show you some of the things we're doing down here because we're in the middle of a virtual production in-camera VFX shoot using Unreal Engine to drive these LED walls. We've got a few different scenes we're shooting, so let's go down and take a look around. So the operator would be here actually controlling Unreal Engine. So all the information that we're talking about, moving the screens around, the tracking of the cameras, the information from the focus of the camera, that all gets funneled into Unreal Engine. And then the operator's here and they can control the whole scene in real time because it's all being rendered in real time. So if the DOP's like, oh, I need more light here, or let's rotate the world slightly, let's get the sun coming in from a slightly different angle, that can all happen here in real time. We've been working with the virtual production tools in Epic for years now, I think, in terms of whether that's virtual camera on lookup stage or iPad cameras with the AR kit or performance capture coming out of the engine. We've been exploring those things. So I think one of the successes of an in-camera VFX shoot like this is preparation and going into it and pre-visualization and knowing what you're going to shoot. So that, like when we built this, we considered making a static and LED wall configuration, but it made far more sense to have everything flexible because we can move the vehicles, we can move the screens, we can have them up, they can move up and down on motors, everything is completely configurable. And because we have the QR code system, which lets us track where all the screens are at any time, we can have that dynamic movement and we can give the director and the creatives any sort of control over how they want to change it on the day rather than it being a fixed setup. We're testing some new virtual production technologies, some of which will be in 426, but we're working closely with Epic to test those out, give them feedback, explore them, help them, develop them. We've done a lot of projects over the years, and each time we do, we try and push real-time technology in some way. We work as partners and push that tech, and we had the smog thing, and then we've launched ARKit with Apple, we did that with Epic, and then we've done live events like concerts like Childish Gambinos Feroz through to this virtual production thing we're doing here. 426 has a lot of cool new features in it, and we've been exploring hair and fur in that system, and Weta's got a long history of creating creatures, hairy creatures from the Apes franchise, Umbrella Academy, a lot of other ones, and we've been wanting to say, like, how far could you take a movie quality hair and fur system and push that straight data into the engine and see what happens in real time.
Hello, my name's Keith Miller. I'm the Creative Director and Visual Effects Supervisor for the Special Projects team here at Weta Digital. And today I'd like to give you a little bit of background on a project that we've been working on and we'd like to share with you today. So at Weta, we've got a pretty long history of working with filmmakers and helping them to tell their stories through visual effects. So we develop characters, we build worlds, we work to advance the technology as required to support that storytelling and that filmmaking process. What we've been starting to see over the last few years really is real-time technology increasingly becoming a part of the filmmaking process. And that's across the board really. I mean, everything from previs through to final pixels in some cases. So when we think about Unreal Engine, we approach it as a framework, not only for background in-camera content during production, as Alistair just showed us, but for producing final pixels for hero animated content. So we wanted to push beyond the static backgrounds that we're used to seeing for kind of modern in-camera LED wall productions and really see what's possible when working with animated content and characters. So we put together a small in-house team to explore this idea and create a fun little animated short that we're excited to present for you now. So I hope you enjoyed our short. I know we certainly enjoyed exploring new workflows on the project. Traditionally for us at Weta, we're used to adapting feature film VFX content for real-time use cases. So that's VR, AR games, or maybe even proxies for our own real-time renderer for lighting and animation purposes. That process of optimizing for real-time, it's constrained when the fidelity is driven by the performance requirements of the target systems. So we were keen to explore working the other way around from that traditional film to real-time scenario. So we wanted to ask the question, what if we were developing content purely for a scenario where we can create assets from scratch for production of linear narrative media? Are there real-time workflows that we can leverage for producing rendered media in that fashion? Can we work in real time and take advantage of those processes without having to overly worry about performance throughout, and then still render to create pretty pictures? So let's jump in and take a quick look behind the scenes in a couple areas. So one area we were particularly excited to explore was the strand-based hair system that was introduced in 424. So we started working pretty closely with Epic into 2019, where we're using some existing ape assets to push the integration of Weta's proprietary fur system with the new strand-based system. So we helped drive the groom requirements, just generally make sure that the systems were able to handle the complexity of a heavily furred feature film VFX asset. So we continued that work into this year with our meerkat and our eagle on this project. Took some trips to the zoo for a reference and began to study their fur in detail. So our meerkat was initially groomed at real-world densities and widths with enough segments along the strands to match the actual curvatures that we would see in the reference. And then from there was some optimization to manage the real-time constraints. But as you can see here, we were able to get pretty solid performance with a dense groom in the engine. This meerkat groom is, I think, somewhere around 400,000 strands. So the feathers were particularly challenging for us in real time, primarily due to the anatomical structure of a feather and some of the rigging requirements, but also just due to the general density required. And just to confirm, these feathers are all constructed from strands. They aren't using cards or anything like that. So the eagle groom that you can see here is somewhere around 2.5 million strands, and the shaft of each feather is geometry to allow for rigging, and then the barbs on each feather are constructed from strands that are grown along the shaft or the rachis. As much as possible, the shaders were built to mimic the same biologic principles that govern real hair and feathers. Studying the growth patterns, the proteins that are in charge of the pigmentation, and the release timing mechanisms, that's all key to replicating the patterns that we see in specimens of meerkat fur and the martial eagle feathers. And all of the banding and patterning that you can see here was handled procedurally in the shaders to replicate those processes. So another tool we explored during production was Unreal's Live Link. And while we had already been using that in production to some degree for bringing performance capture into the engine, this was the first time that we used it with animators working inside Maya. That's really important for them to be able to evaluate their posing in the engine under the actual shot lighting and with the fur volumes in place. And that's really helpful for them since they can get an understanding of how the shapes and the volumes read, since it's something that's normally much slower to iterate on and refine. And the project itself was actually quite performant and able to run at blazing speeds on the NVIDIA 3090 that I have in this machine. And you can see me here just kind of playing it down in the sequencer, and the frame rates are rather high, even with all the fur in place. But even as performant as it was, we knew we wanted to leverage everything we could throw at it for final quality renders. And that way we could take advantage of large numbers of temporal samples and really crank up the detail by controlling a number of the variables at render time. So we've wired up some quality switches like this one, where we could force a lot on the environment for renders and use a crazy amount of geometry for detail without impacting our interactive workflows in any way. So we're really excited that we were able to share this work with you today and are looking forward to continuing to push the technology and see how far we can take this. Thank you.